Hi, I've been asked to solve question 4 from the Level 2 Physics 2005 Mechanics paper. So here's question 4. Here we go. Okay, it's a circular motion and torque question. Janet swings a ball tied on a string in a horizontal circle above her head. Explain why the ball is accelerating even though it's swinging at constant speed. Okay, so here's the thing. So you might think, how can something accelerate if it's going at constant speed? Because you probably learned that it's only changing speed that causes acceleration. Now, what we need to remember is that acceleration is a vector. So if either the speed or the direction changes, then the object is accelerating. Okay, and so, okay. So a ball is swinging in the circle at constant speed is accelerating, and what does cause acceleration is this unbalanced force, the centripetal force, which acts at 90 degrees to its velocity, and that causes it to change direction. Okay, then the length of the string is 0.75 meters, so that's actually the radius of the circle. So if you've got a string with a ball going around, that's the radius. Okay, and the time taken for it to go around the circle once is 0.84 seconds. So you need to have v equals d over t, but the distance around a circle is 2 pi r over t, time taken to go around the circle once. So you get your v, and then you get your acceleration by using v squared over r, and you get your answer. Moving on to the next question, name the force that causes the ball to accelerate as it goes in a circle and explain why this causes it to accelerate. So it's the unbalanced force that's called the centripetal force, that's the name of the force, and it acts at right angles to the instantaneous velocity that causes it to change direction and hence to accelerate. Now, because the centripetal force, it acts towards the center of the circle and it acts at 90 degrees to the velocity. It has no component in the direction of motion, so it does not increase its speed, but what it does is it changes its direction of motion, and I've just drawn a diagram here. So that's your instantaneous velocity, which keeps changing as something goes around a circle, and the force that causes it to change acts at right angles to it, so it doesn't increase the speed, but it causes it to go in a circle. And then the last one is a torque question. So here's a table that has 2 panels at each end, and there's a pile of books over here, and we've got all the details. So what I've done is draw all the forces acting. So that's the force of the books, gravity force of the books, and there's the weight of the table, and then I also get my distances. So you know this distance, you know that distance, and this whole thing is 1.5 meters. And so you need to state this, taking B as the pivot. So you need to find A, so you need to take the other one as the pivot. Taking B as the pivot at equilibrium, your sum of clockwise torques is equal to the sum of anti-clockwise torques. So how do you know what's clockwise, what's anti-clockwise? You start from B, you go along the table till you get to the arrow, and that's your anti-clockwise torque. And then you start from B, go along the table, come in the direction of the arrow. Your torques. Okay, so that's what I've done. So FA times 1.5 torque is force times distance. So that's your force times the distance plus the other force times its distance. And then you do that and you get, and then you add these two, you divide by the 1.5, and you end up with the answer. So hope that